Hey, we're chugging our way through chapter 2 here in our algebra topic, and today we're going to focus exclusively on finding the equation of a line. Just a monster topic here. So a couple of things you can anticipate seeing in the video tonight. First of all, we're going to find the equation of a line if based on giving us the slope and a y-intercept. Okay, that's not going to be too bad. We're going to make that look real easy. We're also going to find an equation of a line who has a given slope and passes through a given point. That's going to be just a tick more challenging. And then ultimately what we want to get to today is find the equation of a line passing through two given points. And that's where we're really going to get into some nice algebra and give you a couple different variations and options there. But really our goal today is to find the equation of a line based on various given information. As you saw in those three examples, they're going to kind of mix up what kind of characteristics they give us. And we're going to try to sift through that, sort it out in our heads, and come up with the best equation of a line. And that real big bear right here is if we're given 2 points, that is kind of like the culminating act today. So again, three different variations of a line that you may see from time to time. And sometimes, folks ask me which one's my favorite, which one's the best. It always depends on the context of the question and what exactly our task at hand is. But we do have the standard form. To be honest with you, this is probably the one I use the least, but sometimes it's nice when it's, as you're working through that equation to kind of rewrite it in that form when you're all said and done. But then we're also going to spend a majority of our time on the slope-intercept form today. And at the end of the video, we're also going to introduce you to this point-slope form. And that is really handy, in certain cases there. So let's see if we can tackle this first example. Can we find the equation of a line that has a slope of 4 and a y-intercept of 2? So again, y equals mx plus b is going to be our bread and butter. That's going to be the one we go to most often today. And all we're going to do is substitute a 4 in for the slope, and we'll substitute this -2 in for b, and we'll rewrite it as y equals 4x minus 2. And this is a perfectly fine, acceptable answer right there. Now, the only thing I could anticipate is maybe there was a set of directions that said we really want this in standard form. And if that was the case, what I would do is we want to get the x and the y on the same side. So you could say -4x plus y equals -2, or we could go through and divide everybody by -1, which would be preferred here. And as we change all the signs, so this would be my standard form, but it's 100% equivalent to this bear right here. The next challenge here is, what if we had a slope of 2/3 and we knew it had to pass through this point? So let's assume that I still want to use my slope-intercept form, okay? And right out of the gates, I can take my 2/3 and substitute that for m. That's no big deal. Now what I'm going to do is I don't have the y-intercept like I did in that last example. So I'm going to treat this 6 as my x and this -1 as my y and substitute those accordingly. So we could say -1 equals 2/3, and then we'll substitute the 6 for x. And we're going to use this to solve for b. So -1 equals, when I multiply the 2/3 and the 6, I get 4. We'll subtract the 4 over to get -5 for b. And all we're going to do is take that -5, sub it back in for b, and we could say y equals 2/3 x minus 5. And again, as far as we're concerned, that's a great answer right there. Okay, so here is the real meat and potatoes of today's lesson. We know that our line has to pass through this point and this point, and I would really like to know the slope. What is the slope? Using the letter m, we know that slope is the change in y divided by the change in x, or we like to say rise over run. So let's say that I want to, let's see, the -4 is my first x, and the 2 is my first y. 6 is my second x, and 7 is my second y. So substituting those accordingly, I'm going to get 7 minus 2 all over 6 minus -4. We've got 5 over 10, which simplifies to 1/2. Now, believe it or not, we could pick, we're kind of at the point where we were in that last example. We've got this slope and we've got a point, and it really doesn't matter which of those points you pick. I'm just going to go with the first one just because it's the first one, I guess. So I'm going to substitute, let's see, we're working off of y equals mx plus b, so we'll substitute the 2, the 1/2, the -4, and then we're going to solve for b. So 2 equals -2 plus b, or in other words, 4 equals b. If I sub it all back in, we could say y equals 1/2 x plus 4 is the equation of my line. Now, I think worth noting here before we totally abandon this and move on is, let's say I didn't want to use this point and I want to use 6, 7. I could have put a 7 here. I could have put a 6 right here, and I would have totally gotten the same y-intercept, believe it or not. Isn't that cool? Okay. Now, let me introduce you to my best friend here. And maybe if I did have to pick a favorite of those 3 different forms of a line, this is probably the one I would pick. It's the one I have found most useful at all levels of math. And we're getting into the idea that, okay, if m is my slope and I know it passes through a point, I can come up with an equation in what we call point-slope form. And here's where it comes from. Remember how we just said the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1? Well, what I want you to imagine is yourself cross-multiplying. So let's multiply down this diagonal here first. Whoops, that should be a 1 equals, and then we'll multiply down this diagonal here. So we've got m quantity x sub 2 minus x sub 1. And really what we're going to do is, in essence, we're going to erase those sub 2. So y minus y1 equals m x minus x sub 1. Now, we're going to, so like we said, we're going to, let's see, we're going to substitute our slope for m, and then we'll take this point here and we'll substitute it for x sub 1 and y sub 1. And then we do not substitute anything for this x or this y. Those are the variables that'll still be sitting in the equation when we're all said and done. So I think it's important to have a strong idea of what we're substituting for and what we're not. So again, let's just rewrite the formula here. And I'm going to substitute, let's see, we're going to substitute the 2/3 for your slope. And let's see, we're going to substitute the 6 in for this guy right here. And let's say we're going to substitute that -1 in for this guy right here. So let's see what that looks like. We're going to go y minus a -1 equals 2/3, and we'll go x minus 6. First thing I noticed is I did have 2 negatives right here, so we'll go bang, bang. We'll turn those into a plus sign. So I got y plus 1 equals, I can distribute the 2/3, and that's going to make 2/3 x minus 4. And then I just subtract that 1 over to make minus 5. And there is an equation of a beautiful line, and you'll notice it matches the same answer we had earlier given the same criteria. All right, let's put the finishing touch on this lesson here. And again, we've got our first x and our first y. We've got our second x and our second y. And it doesn't matter what form of the equation you use, we still have the same dilemma that we had on an earlier example, and that's we need the slope. So first things first, to find the slope, we're going to find the change in y. We're going to find the change in x. We got 5 over 10, which simplifies to 1/2, so that's the same result as earlier. And now I'm going to substitute that 1/2 in for m, and you could pick either of these points that you want. I'm just going to go with the first one, no particular reason. So we got y minus 2 equals 1/2 quantity x. Now I want to say minus a -4, and that turns into x plus 4. If we want to distribute the 1/2, and we'll add that 2 over, so we get y equals 1/2 x plus 4. Boom, there is that final answer. So some really nice moves there as far as writing equations of a line given different characteristics about that line, whether they give us the slope or we've got to find the slope. I think we're ready for anything they throw at us.